Okay, here's the next type of second order differential equations that we're going to deal with. And this is just an inhomogeneous one. So if it was a homogeneous one, there'd be a 0 here. This is just inhomogeneous. So how do we solve this? Now, the first step is we take this and we're just going to write it as a homogeneous equation. So y double dash minus 2y dash plus y equals 0. And we're going to solve this as we did before. So this becomes lambda squared minus 2 lambda plus 1 equals 0. And we can solve this. So lambda minus 1 all squared equals 0. Therefore, lambda equals 1. Therefore, our complementary solution, or the start, equals C1 e to the x, or 1x, plus C2 e to the 1x. Again, these two are linearly dependent, therefore we have to put an x in there. So that is the start of our general solution. Now, the next part is to get our particular solution. So y particular. And this is where we sort of have a guess. And we can have a guess in this case because this side is y 3e to the 2x. So let's assume that our answer is going to be something like ae to the 2x. And that's a fairly good assumption. And so y dash is going to be 2ae to the 2x, just differentiating. And differentiating again, we get 4ae to the 2x. And now we can take these three things and sub them into our original equation. So we're going to substitute them into here. So what we get is we get y double dash, which is just 4ae to the 2x, minus 2 times y dash, which is 2ae to the 2x, plus just ae to the 2x. So all I've done there is I've taken these things, y double dash, and put it in here, y dash and put it in here, y and put it in here. Now what we know is that this equals 3e to the 2x. That's why I can say that it's a pretty nice guess, actually, because you can see that we can find a value for a that's going to make this work. So what do we get really is 4a minus 4a plus a equals 3. Now, we could have put the e to the x's there, but really we didn't need to. 4a minus 4a, so a equals 3. It doesn't always work out that nicely, but our particular solution, y particular, is when a is 3, so 3e to the 2x. Now, in this case, it's worked out that it's exactly the same. It won't always do that. That was don't think that that's always going to happen because it won't. So our general solution, and that's what we're trying to find, our general solution is just our particular solution, our complementary solution up here when we solve for the homogeneous one plus this. So you just get C1e to the x plus C2xe to the x plus 3e to the 2x. Now, the other thing that you need to be aware of is if this changes from an e to the 2x, your guess is going to change as well. So if this isn't an exponential, if it was a sine or a cos, if you had this function again, y double dash minus 2y dash plus y equals sine 3x, then your initial guess, your y you would guess it as a sine 3x plus b cos 3x, because the 3x isn't going to change. And then when you get y dash, it's going to be 3a cos 3x minus 3b sine 3x. And again, y double dash. So you can see that the sines and coses aren't going to change. So it depends on what you've got here. And if it's a nice simple equation, e to the x, or sine, or sines, or coses, if this was a cos, you'd do exactly the same thing. Okay? And again, you would double dash this is going to be 9a sine 3x minus 9b cos 3x. Better put a minus in there. And again, we would look at these and find some simultaneous equations to find the value of a and b. And again, that would be our particular solution for this value over here. Okay, hopefully that helps a little bit. Thanks. Where is this? Okay.